Let's talk about winning strategies for that probability game that you've just experimented with. What kind of strategies did you come up with? Well, in my face-to-face class, we had some of these strategies. I'm assuming that they'll be close to what you figured out as well. Put blocks on 6, 7, or 8. Maybe put most of your blocks on those numbers. That was a very popular strategy. And don't put many blocks on the outer numbers because they don't happen very often. That makes sense. And never put blocks on 0, 1, or 13 because there's no way to roll those sums. And I think some of you might have initially put blocks on those numbers and then quickly realized they were never going to happen. So one die has 6 sides, and the probability of rolling any particular side, like a 1 for example, is going to be 1/6. We already know that. And if you're rolling 2 dice, does that make the probability 1/12? Well, no, it doesn't. And here's why. We can write out all of the possible sums that you can have, and as you know from your experimentation, that's going to give you numbers between 2 and 12, and you can't have any other sums when you only have 2 dice to work with. And the number of ways that you can get this sum of 2 is just 1. It's a 1 on the first roll and a 1 on the second roll. And then we can think about each of the sums that you can get from 2 to 12 and how many different ways you can get each of those sums. And that's going to help us figure out the probability. So let's take a look. If we're thinking about 3, you could have a 1 on the first die and a 2 on the second. That would give you a 3. Or you could have a 2 on the first die and a 1 on the second die, and that would also give you 3. And there are no other ways. Now notice that we're talking about the first die and the value on the first die for each of these sums. That'll be that first number there. And then the value on the second die is the second number there. And so there are 2 different ways to get this sum of 3. And in this way, we can fill out our whole chart. And so all the numbers 2 to 12, and here's all the ways we can add up and get each of those sums. And you can see here towards the middle, the 6, 7, 8, there's a lot of ways to get those. In fact, the 7 has 1, 2, 3, 4, 5, 6 different ways of getting that sum of 7. So that would be a good reason why you would want to put a lot of blocks on 7. And then what is the probability of any particular roll? For example, if you want to roll a sum of 7, what's the probability of getting that roll? First, we need to count up the ways to get a particular sum. How many of those ways do we have? And that's from our previous table. So here it is. Here's 1 way, 2, 3, 4, 5, 6. So I'm just counting them up as I go. 7, 8, 9, 10. And then I add all of these up. I end up with 36 ways to roll all the different sums that you could get. So 36 ways. Then, so from still thinking about a particular roll, the probability of any particular roll combination is 1 out of 36. And that's because the second die roll is not dependent on the outcome of the first die roll. So if you roll that first die and you get a 3, that does not change the probability of what you will get for your second die roll. It's independent, completely independent of what you got on the first die roll. So that's what we're saying there. And because of that, we have 36 possible outcomes. So let's calculate the probability for each of those sums that we had. And looking at our chart, when we had a sum of 2, there was 1 way to get that sum, so it's going to have a probability of 1 over 36, 1 out of 36 possible ways to get a sum. And if we just take 1 divided by 36 and then of course multiply by 100, we're going to get a 2.7778% likelihood of rolling a 2. Not very high, but that's what it is. Let's look at 3. For 3, there were 2 different ways to get that sum of 3, and that is 2 over 36 ways, and that reduces to 1 over 18, or a 5.5556% chance of getting a 3. We do the same thing for each of the numbers 4 through 12, And you can see that those the likelihoods are increasing up to a high of 16.67 for the 7, and then decreasing again down to the likelihood for the 12, which is 2.7778% as well as the 1. So you can see the probabilities here for each of the sums, and if I add all of these up, and 1 over 36 plus 2 over 36 plus 3 out of 36, then that's going to be like 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21, and so on. And I can add up all of those fractions, and I end up with 36 over 36, which is equal to 1, which is 100%. Now, just a note, I don't necessarily, if I have the fraction probabilities, I prefer to add them because it will come out exact. But when I do this division, 1 divided by 36, you can see I had to round here, and that rounding is going to make my sum be off just a little bit. So I would prefer to just add up my fractions and show that it is 100%, rather than add up all my decimal values and then be off by a slight amount because of rounding. So it does total 100%. And this is why we would want to put most of our blocks on 6, 7, and 8, because they have definitely the highest probabilities of being